Lesson 9, we are talking about graphing quadratic functions from factored form. There's a do now up here that we've, just solving equations algebraically, either factoring and setting the solutions equal to 0, moving terms around, again, factoring using the AC method. So on to, given an equation, can you figure out where this graph across the x-axis? So if we were to graph this equation anyway in general, where it's going to cross is where it's going to cross on the x-axis are called roots, or called the x-intercepts of the quadratic, right? It's right across the x-axis. Or we call these the solutions. So where I had you solving for where I've had you solving for x, those are the solutions. So here's one part where it's crossing at x. And you can see on GeoGebra, this is a graphing calculator, they're telling you the root is 4, 0. That's an x-intercept. And if we go over here, it's a really big parabola. Another root is negative 10, 0, which I've listed here. So if you were to, solve this without it, right, if you want a solution to a graph, you're setting the equation equal to 0. Remember, you're setting this y value equal to 0. This is y equals this right here. So to find a solution, you set the function equal to 0. So we're given the solution, we set it equal to 0, we factor this, right? We can't really solve. So what two numbers multiplied to negative 40 and add to 6? So let's think about it. We have 8 and 5, 10 and 4 would work. But we need to make it a negative 40 and a positive 6, so we can make the 4 negative. Factor by grouping, or you can write it the simpler way, so x plus 10, x minus 4. But again, we have to set them equal to 0 to find the solution. So you would get this after you factored by grouping equals 0. You're setting both equal to 0. So we have x plus 10 equals 0, x minus 4, x minus 4 equal to 0. So then x equals negative 10 and x equals 4, right? 4 minus 4 is 0. Negative 10 plus 10 equals 0. So these are my two solutions as what it was showed on GeoGebra on my graphing, on the graph. So again, these are called the roots. So the solutions to, they're called zeros, roots, or the x-intercepts of our quadratic, okay? Those are the three names, and that's where we've been solving for. A way we can write the roots in factored form. So if we go back, right, this is factored form. So our roots have that similar look, as you can see here on my left, of x minus a, x minus b. And the roots are just like those opposite, right? We have x plus 10 here, but our answer is negative 10. We have a minus 4 here, but it's a plus 4. They can look different. So depending on the graph, so this graph, x squared plus x, is in the blue, but the red also is that same graph. So these two, this is the normal form and this is the factored form, and they are actually equal to each other. So you see the red and blue are overlapping, g and h, because they are the same function. The blue is just the quadratic form, and this is the factored form. So they can look different, but they can have the same roots. Okay. All right. In the last lesson, we learned about the symmetrical nature of quadratics. How can we use the information to find the vertex? So axis of symmetry is halfway between the roots. Use that as x value to find the y coordinate. So again, you can find the x value of the vertex, which is in between those two roots. It's kind of like the midpoint of those two roots.